Today we're doing section 3.4, day 3, and we're going to be doing some more solving of exponential and log equations. So just like how we finished the video yesterday, we're going to have to condense first before we can put in exponential form. We look at the sign between the two logs, which is subtraction. So we are going to condense using the quotient property. So I have x plus 2 over x minus 5 equals 3. And now we need to put it in exponential form, so it will look like this. It'll be 2 to the third power equals x plus 2 over x minus 5. 2 to the third power equals 8. To clear the fraction, we're going to multiply both sides by the denominator of x minus 5. Squeeze that in over there. Okay, so on the left side, I have 8x minus 40. On the right side, I have x plus 2. And now it's just a simple algebraic equation. I'll subtract the x over, giving me 7x, and I'll add the 40 over, giving me 42. Divide both sides by 7, and we get x equals 6. So once you put it in exponential form, it's not a terribly difficult problem to do. Now, letter B is a little different. So letter B, I have condensing, so I have two logs on one side. I need to condense it, but then I have a log on the other side. So let's work with the left side first. When I condense it, I get the quantity of x plus 2 over 4x plus 3. And it's equal to the natural log of 1 over x. So this one's different from letter A because I have natural logs on both sides, not just one side. So I'm not going to put it in exponential form. We're kind of almost going to treat it as if I had the same base on both sides. I have the same log on both sides, so I drop it, and I'm going to set the insides equal to each other. For this, we can kind of do some cross-multiplying if you want, or we could go in stages. Might be easier to go in stages. So to clear the right fraction, I'd multiply by x. When you're multiplying by x, you're technically multiplying by an x over 1. So a common mistake is students will multiply top and bottom by x. That's not true. You're multiplying by x over 1. So in the numerator, we get x squared plus 2. Bottom stays the same. To clear the bottom fraction on the left side, we're going to multiply by 4x plus 3. And over here, 4x plus 3. So we end up getting, let's see if I can make some room, I'll erase this. We end up getting x squared plus 2 equals 4x plus 3. So get all our terms on one side, let's bring the left side over. So I'll have x squared minus 4x. If I subtract this, 3 over 2 minus 3 will give me negative 1 equals 0. Now, when I go to see if I can factor this problem is not factorable. Nothing multiplies to be negative 1 and adds to be a negative 4. So we are going to have to do quadratic formula. I'm going to erase a little bit of this work over here so I have more room. So for quadratic formula, we know it's negative b, so this will be a positive 4. Then I'll have a negative 4 squared, which is 16 minus 4 times a times c. All over 2a. Underneath the square root, we have 16 plus 4, so I have the square root of 20, which breaks down to be 4 and 5, so 2 root 5. So coming back over here, I have 4 plus or minus 2 root 5, all over 2. The 2's are all going to cancel, and I'm left with 2 plus or minus the square root of 5. Not that they're canceling, they're all kind of reducing by a unit of 2. So that is our final answer for letter B. So a little bit more work required for that one, but again, not too difficult. Lastly, letter C. So this one looks totally different. I have logs on both sides, but I also have regular numbers on both sides. So there's a couple different ways to approach it. I'm going to kind of just show you what I think is the easiest way. That doesn't mean this is the only way. This right here has two numbers. I have log base 2 of 4, and if you remember from evaluating, you would ask yourself, well, 2 to the what power gives me 4? And that answer would be 2. So log base 2 of 4 is equal to 2. So I have log base 2 of x plus 4 equals, so if we determine that this is 2, 5 minus 2 is going to leave me with this, the right side equaling to 3. Divide the 3 over. So I have log base 2 of x plus 4 equaling to 1. And now this turns into an easy problem like what we did yesterday. Put it in exponential form. 2 to the first power equals x plus 4. 2 to the first power is going to remain 2. I'm going to subtract the 4 over, and I get x equals -2. And again, I would want to check just to make sure. If I put a -2 in there, -2 plus 4 is still a positive, so we're okay. This problem, this one would work, and it's not a no solution. All right, that's all for today.